Hey folks, this is section 4.3, and I'd like for you to go down a little ways and take a look at the example for number 14 and number 18. A couple of things that we're going to be going over in class. You want to always be sure to check your answers, because if one of your answers causes there to be a 0 on bottom, you must throw that answer out. The directions here would say to find all solutions by hand. No calculators, as in no graphing on the calculators. I don't mind if you use add, subtract, multiply, divide. Those things don't bother me, but no graphing. Some tips that I have. First of all, get a common denominator. That's what CD stands for, get a common denominator. So let's take a look at number 14 first, and let's talk about getting a common denominator. Often, in order to get a common denominator, you have to look at all your denominators and make sure they're factored completely. And I noticed that my first denominator is not factored completely. I can factor that to 2x minus 1 times 2x plus 1. Now, in order to get my common denominator, and I'll come over here to the side to do this, the method that I typically use to get a common denominator is, first of all, use all of the first denominator that you have. That's automatically going to be part of your common denominator. So I'll write that part down, 2x minus 1, 2x plus 1. Then you'll move to your next denominator and you'll ask yourself, do you have any repeats of factors? Do I have any repeats? So I do. Notice 2x plus 1 is already being used, so I don't need that one. So then move to your last denominator and ask the same question. Do I have any repeats of denominators? Any repeats of factors? And yes, I've already used that one, so I don't need to use it again. So my common denominator on this question is simply 2x minus 1 times 2x plus 1. In my tips, the next tip is that you're going to multiply every single term by the common denominator. So I'm going to take the entire equation and I'm going to multiply by 2x minus 1 times 2x plus 1. Realize I'm only multiplying on the top because the bottom is actually a 1. And you say, why is it legal to just up and multiply by something? Notice I'm actually multiplying on both the right side and the left side of my equation. And that's completely legal. You can always multiply on both sides by something. So I'm going to take this common denominator and I'm going to pass it out to my first fraction. Now, normally I wouldn't write down nearly as much as I'm about to write down with you, but this is a new type of question, so I am. So we have 2x minus 1 times 2x plus 1 times the fraction 8x over 2x minus 1, 2x plus 1. Normally I wouldn't write all that out, but I will for the first question. Then I have the equal sign. Take that same common denominator and pass it to the next fraction. So you have 2x minus 1 times 2x plus 1 times the fraction 3 over 2x plus 1. Then lastly, take that and pass it to the last fraction. So you have a plus sign in between these two. 2x minus 1 times 2x plus 1 times the fraction 3 over 2x minus 1. I'm hoping you can start to see that some things will cancel. So over here, I have both of these guys up on top, but I have the identical things on bottom, so I can cancel 2x minus 1, 2x minus 1, and I can cancel 2x plus 1, 2x plus 1. For my next term, that's this whole piece here, I can cancel a 2x plus 1 on top and a 2x plus 1 on bottom. And then for my last term, I can cancel 2x minus 1 on top, 2x minus 1 on bottom. Now let's take a look at what's left. For that first term, the only thing that's left is 8x. Pull down your equal sign. For the next term, notice I have a 2x minus 1 times a 3. I'm going to go ahead and multiply these two together using distribution. So 2x times 3 is 6x, and a negative 1 times 3 is a negative 3. And then for my last term, notice that all I have left over is a 2x plus 1 times a 3. Once again, use distribution. So you have here a positive 6x plus a 3. Now, I think you would agree with me that this equation to solve is much, much, much simpler than the original equation was that I had to solve. But folks, these are equivalent equations. So all I need to do now is simply combine like terms. So I have 8x on the left. I have a 12x plus 0 on the right. I'm going to take my 8x over to the right-hand side. 12x minus 8x is 4x. That leaves me with a 0 over on the left. If I divide on both sides by 4, I will have x equals 0. Now let's go back up and look at that tip list. First of all, get the common denominator. I did that. Secondly, multiply every term by the common denominator. I did that. Thirdly, I solved, and I did this by combining like terms. Fourthly, this is important. Check your answer. Our answer is x equals 0. If I take that x equals 0 and I bring it back to the original equation and I plug it in for all the x's up in the original equation, will any of my denominators become 0? Because remember, I'm not allowed to have a 0 on bottom. If I plug in 0 to the first fraction, I will not have a 0 on bottom. If I plug in 0 to the second fraction, I will not have a 0 on bottom. And the third fraction, I will not have a 0 on bottom. So my x equals 0 is a good solution. Now let's do the same thing for number 18. And I've already partially worked this out for you. I've already gotten a common denominator for you. So my common denominator is x squared. And so now I need to go and multiply every term by x squared. So I have an x squared times a 1 minus an x squared times the fraction 3 over x minus an x squared times the fraction 10 over x squared equals x squared times 0. Let's clean that up a little bit. For that first fraction, nothing will happen. It will just simply be x squared. For the second fraction, one of my x's on top and the x on bottom will cancel, leaving me with just a 3x. For the third term, x squared on top, x squared on bottom will cancel, leaving me with a minus 10. And this is going to equal x squared times 0, which is just 0. And oh my goodness, look at what we have. We have a quadratic. How many methods do we have for solving quadratics? Ah, yes, we have 4 methods. I'm personally going to choose factoring. You know that's my favorite. You're not locked into factoring. You could have chosen completing the square or the quadratic formula, but I like factoring. So I have an x and an x. For 10, I'll use a 5 and a 2. Since I need a negative 3 in the middle, I'll make my 5 negative and my 2 positive, checking my work along the way. Go ahead and continue solving. We have x equals 5 for the first factor, or x equals negative 2 for the second factor. Please make sure you go back and check. Does either of these solutions cause a 0 on bottom when you plug them back in? Well, no. If I plug in a 5 here, it's not going to be a 0 on bottom. Or here. If I plug in a 2 here or here, neither of those is going to cause a 0 on bottom. Both of my solutions are good solutions.